Good morning. Here we are on our second week of dilations, and our objective is I will be able to identify the scale factor between shapes and perform dilations on a coordinate grid. This is stuff we have started looking at last week, and we're just getting another day of practice. So here's our first example. Parallelogram EFGH, right here, EFGH, is similar to parallelogram WXYZ. What is the length of WZ, given the information above, or in this case, given the information that we just got? So if we know that 2 inches is FE, and 2 inches becomes 4 inches, well, then we can develop our scale factor. Our scale factor is our new shape or a new length divided by our old length. This should look somewhat familiar from 7th grade when we did scale factor drawings and calculations. It's the same thing as that. So in this case, the scale factor is 4, which is our new length, over 2, which is our old length. 4 over 2 is 2, so our scale factor is 2. That means that all of our lengths from the original shape are getting multiplied by 2 to get to our new shape. You could also just see that 2 times 2 gets us 4, which means that 3 times 2 gets us 6. So what is the length? The length is 6 inches. What is the scale factor for the dilation EFGH to WXYZ? Well, we found that the scale factor was 2. What is the scale factor for the dilation from WXYZ to EFGH? Well, that's the opposite. So in this case, it would be, this scale factor would be whatever WXYZ is over EFGH, in which case this would be, oops, sorry, that's wrong, other way around. We're going from WXYZ to EFGH, so we're going the opposite, from 6 to 3. What are we multiplying by? Well, we have 3 over 6, which is going to reduce to 1 over 2. So our scale factor from small to big is 2. Our scale factor from big to small is the reciprocal, which is 1/2. We're multiplying 6 by 1/2, multiplying 2 by 1/2. What does it mean if the scale factor of a dilation is between 0 and 1? Well, just like we saw if we go from this shape to this shape, it means that the dilation gets smaller. Whether that's a decimal or a fraction, if it's between 0 and 1, it gets smaller. Okay. Now we have a couple of examples to do together. So, find the scale factor of the dilation in each picture. We have figure 1 and figure 2. And I'm just going to pick one length to do for both of these. I'm going to pick this length right here. You could also pick this length. So I see figure 1, I'm going to count the boxes. 1, 2, 3, 4, 5, 6, 7. Figure 1 is 7 blocks long, and figure 2 for the same length is 0, 7, 8, 9, 10, 11. So my scale factor, remember, is my new over my old, so figure 2 over figure 1, which is going to be 11 over 7. So I have my new shape divided by my old shape. For this one, see we have these primes right here. That means that this little one is our new shape. I'm going to use FG and then f prime g prime. And my scale factor is going to be my new length over my old length. So fg is 1, 2, 3, 4, 5, 6, 7, 8, 9, and f prime g prime is 1, 2, 3. So in this case, my scale factor is 3 over 9, which is equal to 1/3. Now, here is our question. For this one we have 1/3, and for this one we have 11/7, which is the same as 1 4/7. Why is one scale factor greater than 1 and the other scale factor is less than 1? Well, greater than 1 creates a larger shape, and less than 1 creates a smaller shape. If we have a scale factor of just 1, the shape is going to stay exactly the same. Okay. So a couple of rules, a couple of truths. A dilation produces a similar shape. A similar shape has equal angles and proportional sides. You should remember this word from last year. Proportional is when they're multiplied or divided by the same number. The center of dilation is the point from which the figure is shrinking or growing. This will almost always be 0, 0, or the origin until you get to upper level geometry. Okay, so now we practiced finding the scale factor. Now we're going to practice using the scale factor. So we want to dilate square ABCD by a scale factor of 2 with the center of dilation 0, 0. Before you start, envision the new shape. Based on the scale factor, what should the new side lengths of the square be? Well, these side lengths are 2 all the way around. And with the scale factor of 2, that means we're doing 2, which is our side length, times 2, which is our scale factor. So that should be 4. They should be 4 blocks long. Based on the definition of similar figures, what should be the measure of A, B, D? And I believe they're asking about the actual new shape. So ABD right here, that's a right angle. And when we expand the shape or we dilate the shape, it is still going to be 90-degree angle. Our angles will stay the same. Okay, so you see that they have already written down the original points. A is at 1, 3, B is at 3, 3, C is at 1, 1, and D is at 3, 1. Now if we are dilating by a scale factor of 2, we are multiplying all of these points, both coordinates, by 2. We've done a little bit of this before. So A is going to be 2, 6, 1 times 2 and 3 times 2. B is going to be 6, 6, 3 times 2 and 3 times 2. C is going to be 2, 2, and D is going to be 6, 2. So now I'm going to plot these points on my new shape. So 2, 6, 6, 6. This is A prime, B prime, 2, 2, C prime, squish it in there, and 6, 2, D prime. So my shape should look like the same exact shape, same angles, just larger. Okay, now let's practice dilating with a scale factor less than 1, so our image is going to get smaller. Dilate the shape by a scale factor of 1/3 with the center of dilation being 0, 0. Now, just like we did here, we're going to first record our initial points. We have F, G, and H. F is at 3, 9. G is at 9, 12. And H is at 6, 6. Notice they picked points that can easily be multiplied by 1/3 for us. So now I'm going to multiply all of these numbers all of these sets of coordinates by 1/3. And I'm going to get f prime, g prime, h prime. So a little bit of number sense here. Multiplying by 1/3 is the same as dividing by 3. If I have 9 times 1/3, I'm going to move these extra papers out of your way. If I have 9 times 1/3, I'm going to get multiply across 9 over 3, which reduces to 3. This is the same as doing 9 divided by 3. So when I'm multiplying by 1/3, I'm really just dividing by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3, 9 divided by 3 is 3, 12 divided by 3 is 4, and 6 divided by 3 is 2. So I have my new points there. Now, if this was not a pretty beautiful 1 over something fraction, we would have to do our multiplication by a fraction for all of these. So now we're going to plot these points. 1, 3, 3, 4, 2, 2. And we're going to label them f prime, g prime, h prime. Okay, you have some work to do on your own. Please use your notes if you need them, and have fun.